Dear student, today I will discuss about the nonlinear elements. So before that, I want to share one thing that in control system we observe that we can easily control the linear system, because in linear system we can easily understand the characteristics, or we can observe the characteristics of the systems. But in case of nonlinear element or nonlinear systems, that is very difficult to observe or to predict the characteristics of the any kind of system. That is why I just want to discuss about some basic nonlinear properties or elements which can be into the systems or plant and make that system nonlinear. If I can understand the nonlinear properties of that particular nonlinear blocks individually, then that will be easier for us to predict or to study the characteristics of that system when that kind of nonlinear properties is some plant or in the some system. So here we can see that there are 9 basic type of nonlinear properties or nonlinearities into the system. Number 1, on-off nonlinearities. Number 2, dead zone nonlinearity. 3, saturation nonlinearity. Next, backless nonlinearity. Number 5, on-off with hysteresis nonlinearity. Number 6, on-off with dead zone nonlinearity. Number 7, Coulomb and viscous friction nonlinearities. Number 8, dead zone with rate limiter nonlinearities. And number 9, relay with dead zone and hysteresis nonlinearities. Among these 9 kind of nonlinearities, we can see that first 4 nonlinearities are the basic nonlinear properties of the system. Basically, the last 5 nonlinear properties are very complicated properties of the system. So today I will just discuss on-off nonlinearities. So for on-off nonlinearities, first I want to show you that. So we can see that here there will be a graph where in x-axis there will be some input and in y-axis there will be some output. So if we give some input to a system or to that nonlinear blocks, on-off nonlinear blocks, there will be some kind of output, and that output is just constant with that particular input value. And when the input is not there, according to that the output will become 0. So for example, we can see that in the graph, when there will be the positive input, then there will be positive, the output will be also some positive value with some gain. Here the gain is, assume that the gain is m. And when the input is negative, then we can see that the output is also in negative domain, and the value of that particular case is suppose minus m. So here is the derivation of that particular on-off nonlinear blocks. Let we assume here that the input xt is equal to x sine omega t. So we just assume there will be a sinusoidal input signal with the magnitude of x, and if we give that one, and suppose we are assuming that we are getting the output y m when the value of omega t is lying from 0 to pi, and when omega t is, the value of omega t is from pi to 2 pi, then the value of yt or value of output will be minus m. So as we can see that this is a sinusoidal function, and according to that we are getting some output. That output y is a symmetrical function, so we do not get any kind of DC component. So that's why the value of a0 is 0, and we can say that the y or output function have some odd symmetry, so the value of an is also 0. So there will be only the fundamental harmonic component, that is Bn, will be present in the systems. When we consider that fundamental component, then we can say that yt is equal to y1t is equal to b1 sine omega t. So b1, if we go for the derivation of b1, then according to the Fourier series analysis, we can say that b1 is equal to 1 by pi integration 0 to 2 pi yt sine omega t d omega t. That is equals to, we can say that as this is a symmetrical function, so we just change the limit from 0 to 2 pi to 0 to pi, and that means we are just taking the only one half, positive half to of the sinusoidal wave, and for that, and we will here we can see that the sinusoidal input is a symmetrical functions, and we are just taking the positive input of the sinusoidal function. So we just step down the limit from 0 to 2 pi to 0 to pi. So for that we just double the total things and out the exact value of b1. Now the equation become 2 by pi integration 0 to pi m into sine omega t d omega t. After integrating the signal, we can see that b1 is equal to 2m by pi into minus cos omega t, limit is 0 to pi. When we put the limit, the equation will become 2m by pi into minus cos pi plus cos 0. After putting the value of cos pi and cos 0, then we can find that 2m by pi is equal to minus cos pi means 1 and cos 0 means 1, so 2. So the final result will become 4m by pi. So therefore y1t is equal to, we know that y1t is equal to b1 sine omega t, that is 4m by pi sine omega t. Describing function is the output function divided by input function. So the output function is 4m pi sine omega t divided by x sine omega t. So finally the magnitude of the describing function will become 4m by pi x, and the angle will be, as the input and output both the signal are sinusoidal signal and the angle is omega t, so there will be no phase difference between the input signal and output signal. As there will be no phase difference, so the angle will become 0 degree. So finally the describing function will become n x omega is equal to 4m divided by pi into x, angle 0 degree. So we can see, or we can observe the characteristics of the system nonlinear blocks, and when we include that nonlinear blocks to a system, the overall characteristics we can see by in the MATLAB Simulink block diagram. So here is the block diagram. In block diagram we can see that there is a input block, that is the sinusoidal input block, and a summing point. This is the on-off nonlinearity. This is the transfer function. Here we assume that the transfer function of the system is 1 divided by s plus 5. You can take any other kind of transfer function. This is the multiplexer block or marks, and this is the output or scope. So if you draw this block diagram in the MATLAB Simulink, you can easily find out or easily observe the characteristics of the total systems. To observe the systems, we take here multiplexer block 4:1 multiplexer, and in this 4:1 multiplexer we take 4 input channels and 1 output channels. So the 4 input channels are, one is the output, this is the output channel, this is the input channel, this is the error signal or error channel, and this thing is only the nonlinear blocks when we give in the multiplexer these 4 channels, and we will get a single output which we can see in the scope. So if you draw these things in the MATLAB Simulink and change your value accordingly as per your requirement, you can easily find the characteristics or observe the characteristics through this block diagram, and you can understand the total nonlinear properties of the system. Thank you.